Okay, this is a video on writing balanced chemical equations. This is not a revision on writing chemical formula. Okay, so in order to be able to balance chemical equations, you must be pretty confident and competent at writing chemical formula. There will be some aspects of revision throughout the video as we go through, however. A few key points I wanted to mention first of all. When you're writing balanced chemical equations, you must take each substance one at a time and consider it on its own as a substance to write its formula. You then have to make sure you use the correct method for writing that formula. Now, you should know that there are different methods for elements as there are for compounds. So when you write an elements chemical formula, remember, the only thing you need to concern yourself with is whether it's monatomic or diatomic. Remember, there are 7 diatomic elements in the periodic table that you need to remember the formula for. And we'll touch on how you write those formulas as we go through. Then, if you have a compound, again, there are 2 methods for writing a compound's formula. You use the prefix method, where the name tells you how many atoms of each element there are within the compound. If you don't have the prefixes in the names at all, then you have to use the valency method using SVSDF. Again, there'll be some examples of this as we go through. Finally, in terms of balancing a chemical equation, when you balance a chemical equation, the number of atoms of each element must be equal on either side of the arrow. How we do that? We add big numbers. So we add big numbers in front of the formulas. We do not change the formula to get the correct number of atoms. And again, this will hopefully become clear as we work our way through. So, if we take our first example, now the first example I've given here is nitrogen plus hydrogen reacts to give nitrogen hydride. So again, I've got left a bit of space so that I can do my working on here. You will find that sometimes you need to do your working and then take the formula back because it can start to become a wee bit messy. So firstly, if we consider nitrogen, nitrogen is an element. And if it's an element, then what I have to ask myself, is it monatomic or diatomic? So I put my symbol for nitrogen down, which is N. It is one of the special 7, it's one of the diatomic elements. Therefore, I put the symbol 2, a subscript 2, and that's it. Hydrogen, again, hydrogen is an element. So I put my symbol for hydrogen down, and I ask myself the question, is it diatomic? Again, it is one of the special 7, diatomic, so I put a 2. Then I have nitrogen hydride. This is a compound. This is a compound ending in IDE, hydride. Therefore, it has the elements nitrogen and hydrogen in it. It's a compound. I have to therefore use either my prefix or my valency method. When I look at the name of nitrogen hydride, there are no prefixes anywhere in that name. There are no mons, dis, tris, tris or tetras. So I have to use what's known as the valency method. Now I'm going to come right down to the bottom here. And I'm going to write my valency method down here, so I'll just move this up slightly. So I'm going to take my SVSDF. S is for symbols. I take the symbols for the elements present, which are nitrogen and hydrogen. V is the valency, which you'll get from your data booklet. And your valency of nitrogen is 3, and the valency of hydrogen is 1. S here means, remember, swap. So I swap my valencies over to give me a 1 to 3. D stands for divide, if I can, to give me a simpler whole number ratio. That's the simplest ratio I can get, so I'll leave it as it is, 1 to 3, which tells me I have 1 nitrogen, which I don't have to show, and 3 hydrogens, so my formula is NH3. That's the formula I now take up to here, so NH3. So I've now written my chemical equation. But what isn't true about this equation, it's not balanced. And look at what I mean by balanced. So I have nitrogen and hydrogen here, and I also have nitrogen and hydrogen here. That has to happen. The same elements have to be on either side of the equation. To be balanced, I also have to exactly the same number of atoms. Now if you look over here on the left, so let's add them up. So I have nitrogen and hydrogen here, and keep them in the same order over on the right hand side. I'm now going to count up how many I've got. On the left-hand side, I have 2 nitrogens and I have 2 hydrogens. On the right-hand side, I have 1 nitrogen and I have 3 hydrogens. I'm not balanced. So what you notice here is that I've got 2 nitrogens here and only 1 here. Now, I cannot, as I said up here, you do not change the formula. I've went to the bother of working out formula for nitrogen hydride. That's at NH3. I kind of go and slip a wee 2 in here just because I fancy it, because it then would balance my nitrogens. Okay? So what I have to do is I have to multiply the whole formula. So if I've got 1 nitrogen and I want 2, then if I put a big 2 in front of here, that now gives me 2 nitrogens. So I can score out my 1 and I can write a 2. But what's happened now is I have to assess the impact adding in that 2 on the other elements. I have 3 hydrogens in nitrogen hydride, but I've now multiplied that by 2, so I've now got 2 times 3, so I've now got 6 hydrogens. So I've balanced my nitrogens, but I've now put my hydrogens even more out of kilter here, but I can now go back to the other side and address that situation. So I've got 6 hydrogens here, and I've only got 2 here. Again, I'm looking to put a big number here that's going to give me the same number of hydrogens. I've got 2 hydrogens and I want 6, so I'm going to put a big 3 in here. 3 times 2 gives me my 6. That's a balanced chemical equation. Important points, formula. Your formula must be correct. If your formula's not correct, you're going to sit there to try and balance it all day long. Second thing to watch out for is that when you multiply, when you put your big numbers in front, you remember to address the impact it has on all of the elements, not just on the one that you're trying to change initially. Okay? Let's try another. So, let's try this one here. So let's try propane plus oxygen gives me carbon dioxide and water. So what I have is a complete combustion here of a hydrocarbon. Now you should know propane is an alkane because it ends in A-N-E. It's prop, which means it's C3. It's an alkane, which means the hydrogens are double plus 2 the number of carbons. So 3 times 2 is 6, plus 2 is 8. Oxygen is an element and it's diatomic. So I put a 2. Carbon dioxide is a compound. It tells me, using this di, it's going to tell me what how many of the elements I have, how many atoms. So I've got carbon and oxygen. The di tells me I have 2 oxygens. Water, so one we just have to know, H2O. So again, what I'm going to do now is I'm going to list the elements and I'm going to keep them in that same order over on this side. So I have 3 carbons, 8 hydrogens, 2 oxygens, 1 carbon, 2 hydrogen, and it's a collective total. So 2 oxygens here and 1 here, which is 3. So if I look at trying to balance now, so again, I've got 3 carbons on the left and I only have 1 carbon here on the right. Can I just shove a 3 in? I have to put a big 3 in front here. That now gives me the 3 carbons that I want. But look, it's also impacted my oxygen. So 3 times 2 is 6. So I've got 6 oxygens here, but don't forget about my wee oxygen over here. So I now have 7. Right, so my carbons are sorted. Hydrogens. I've got 2 hydrogens here, but I've got 8 over here. So how can I multiply this up to give me the 8 hydrogens that I need? 2 times 4. So 4 times 2 gives me the 8 that I need. Super. But again, don't forget the impact on the other. This now means I've got 4 oxygens here. So again, go back to scratch. 4 oxygens here. 3 times 2 is 6 here. So 6 oxygens plus 4 oxygens gives me 10. And my final step is to balance my oxygens. 10 oxygens on the right, 2 oxygens on the left. Multiply this by 5. 10 oxygens. Fabulous. Okay? Next one. Now, this is a tricky one. This is going to bring in quite a few formula writing bits as well. But it's worth it just to recap while we go along. So, first one here, lithium carbonate. Now, lithium carbonate's a compound, but the ATE should send alarm bells off thinking, okay, this is not just 2 elements in this compound, there must be 3 and oxygen must be there too. That means, remember, you're going to have to go to page 8 in your data booklet and use the valency for what's called the group ions or the complex ions, okay? So lithium carbonate, again, I'm going to go down to the bottom and I'm going to put my SVSDF, okay? Now, my symbols for this are slightly different. When I go to my lithium, putting my lithium in as normal, Li, but carbonate, because it's a group ion, we keep it as its group. Now, the symbol for carbonate is CO3 2-. So carbonate, if I write it up here, CO3 2-. But I then need to split that, and I keep my symbol in a bracket, CO3, and I use the size of the charge to give me my valency. Again, this is covered when we do formula writing. My valency for lithium is normal, it's in group number 1, so its valency is number 1. Very important with group ions, we keep the bracket there. I now swap, so 2 to 1. Divide if I can get a simple whole number ratio, which I can't, so I'll leave it as a 2 to 1, which means I have 2 lithiums, and I have 1 carbonate, which means I don't need the bracket in. Okay, I would only keep the bracket in if this was bigger than 1. So my formula for lithium carbonate is Li2CO3. Nitric acid, that's one from topic 4 and topic 6 that we just have to remember. Nitric acid is HNO3. We don't have its chemical name, we'll have to remember its formula. Lithium nitrate, again, ATE, compound. It's got oxygen in it, so I have to go down to the bottom again. SVSDF. Lithium is Li. Nitrate this time, nitrate is NO3-. So my NO3 is my symbol, and my 1- is my valency. Lithium group 1, valency 1. Swap gives me a 1 to 1. It's the simplest ratio I have, so I can't divide it, which means I've got 1 lithium and 1 nitrate. So my formula is LiNO3. Carbon dioxide we've seen already, carbon and oxygen, dioxide, 2 oxygens, and plus water. I'm going to put it in here because I've not got space in my film, plus H2O water. Right, to balance again, let's go. LiCO H and N. LiCO H and N. Lithium on here 2, lithium on here 1. Carbon only 1, carbon only 1. Oxygen 3 here and 3 here, so 6. 3 here, 2 here, 1 here, 3, 4, 5, 6. Hydrogens 1. Hydrogens 2, nitrogens 1, nitrogens 1. Okay, so we're getting quite a big one here, quite a big one here. Look at the next bit. So lithium 2 on the left, 1 on the right. So again, I kind of just shove a 2 in here because I've went to the hassle here in my SVSDF. So what I have to do is I have to put a big 2 here. Okay, I can score that out and see I've now got 2. But look at the impact. I've also got 2 times the nitrogens here. 2 nitrogens. And I've now got 2 times 3 oxygen, so 2 times 3 is 6, 7, 8, 9. So I've now got 9 oxygens, okay? So I've got my lithium seem okay, my carbon seem okay, my oxygen's on the right, my hydrogen's on the right, and my nitrogen's on the right here. So on the right, I have more of these 3 than I do here. And look, they all sit in this formula here. So if we look at this, if I've got 2 hydrogens here, and I've got 2 nitrogens here, and I've only got 1 and 1. And I've got 3 more oxygens here than I have here. So if I look at my hydrogens and double that up to give me the 2 hydrogens that I need, just by chance, 2 times the nitrogen gives me the 2, 2 times the 3 oxygen gives me 6, plus the 3 is 9. Fabulous, that's a big one. But don't let the size of that put you off, because actually that was relatively straightforward. Sometimes if you can't see it instantly, the oxygens maybe was a bit more complicated to try and multiply that up. Go to the next one, because by doubling up the hydrogens, everything else fell into place.
Okay?